And let's get started with the 2017 paper. All right, so scan by scan, cam scanner, we love that. Which of the following what statements is not a part of Dalton's theory of Dalton's atomic theory rather? What's that? Which is not present there.
B.
B.
B as in boy or D as in dog?
Boy.
Okay, B as in boy. But when you start saying D and D, it's gonna be confusing. Give me a second, let me plug in this laptop. Alright. So next question, which of the following factors is important in determining the stability of an isotope? What would that be?
Protons, electrons. C.
Lovely.
C.
Lovely. Alright, the ionic equation for the reaction magnesium with hydrochloric acid is presented here. The molar volume of the gas at RTP is 24 mole decimeter cubes. Right, so the volume of the gas produced is 1.6 grams of magnesium. So, and with HCl at RTP is, what would that be?
A.
A.
Lovely. Right, so if we only will work it out if somebody have an issue with why we get A, right, or anything like that. What would the pi bond be here?
Sir, C.
Why is it not D? Because that is two p orbitals overlapping as well, so why is it not D?
Because it's the side way, not head on.
Okay, lovely. Which of the following statements are true regarding the factors affecting ionization energies? So an increase in the shielding effect decreases the ionization energy, is that true? I think that would be true. An increase in the size of the positive nuclear charge decreases, nope. And an increase in the distance will actually decrease ionization energy. That would be 1 and 3. Alright, next page. Ah, lovely. Right, so we're asked to really look at the relative isotopic mass of lead. What is the relative isotopic mass of lead? Here. This has been worked time and time again. So what's the answer?
The answer is B.
Answer is B. Interesting. Alright, so 27.24 is it, right? I memorized the relative atomic mass. But once you do the equation, what is the equation that we use here? It's sigma isotopic abundance divided by 100, no? So that's,
Times.
go ahead.
Yeah. Wait, never mind, never mind.
Okay, but we should know the equation in order to get that, right? With here now the coordinate bonding, when I was doing structure and bonding, I explicitly put this into my PowerPoint. What's the answer here for the coordinate bonding of the BF3 and NH3, the ammonia and the boron trifluoride? What's the answer? Boron is electron deficient, this won't work. Fluorine, only a madman will choose that answer.
C.
C, lovely, right? And D not gonna work as well because only a mad person will choose that answer as well. All right. Moving on. Oh, look, a beautiful question, right? So the argument for this question, right? People have been saying transition elements, right? Transition metals would be the most suitable answer here, right? And I've also seen arguments, right, that supported the fact that this may be a group one metal, right? So let's hear it now. Mm-mm-mm-mm.
A. Mm.
All right. So I've looked back at the question, right? Because I think I answered the question earlier, right? So I look back. I was looking at the question, right? And I was seeing that people are seeing it's transition metals specifically, and I looked at it and realized that there's a similar trend to transition metals, right? But transition metals simply don't start with such a low ionization energy per se, right? But Ale, could I hear what's your supporting point for this for a second, or why you believe it's transition metals over that of the group one metal? Are you there? I want everybody
So
to
you're breaking
hear.
up. What did you just say?
I want to hear what the supporting point is for transition metal over group 1 metal in this question.
I think it's group one metal. I said A.
Yeah, I heard A. Alright? I heard you said A. But some persons are saying it's a transition metal. I want to hear why we say it's transition. Because the trend is similar to the transition metals, but what my general well, am I going to say prognosis? LOL. Right, would be that this right number is below the first ionization energy of all right the transition elements. Right, I would go with the group one there. With the answer for this, now a student titrated potassium permanganate against peroxide, right, hydrogen peroxide to be specific. The equations are as follows, which are the following equations represent the balanced equation for the titration. What will be the balance equation here? What do we do to balance the equation? I specifically remember teaching this. Right, so we need to equate the number of electrons, right? And then what would have to equate the number of electrons, right? We combine, we equate number of electrons, then we cancel out the hydrogens, right? And then that from that we should get the actual equation, right? The full equation. So how do we treat this? What's the treatment of this question?
So times the first equation by 2 and the second equation by 5. So we have 10 electrons in both equations, so we can cancel them.
Okay, times by 2, we times this one by what, 5? Alright, so you're saying that from there, so we're going to get 10. So the electrons will cancel out as 10, right? 2 8 is 16, right? And when we cancel out that 2 5 is 10, we're gonna get what? Alright, 6 hydrogen on one side, therefore it must not be A and it can't be D, right? Therefore it must be between these two, right? 5 times the peroxide would give us 5, the answer should be B. Answer is B. Lovely. Alright, let's move on. The shape of the complex here, what is the coordinate number of this complex?
A octahedral.
Okay, what's the coordination number though? It is 6. Guys, it is 6 ammonia, right?
6.
Hexaamine cobalt. Alright, lovely. Which of the following groups of solids contain substances of that all have giant structures? If you ever say iron, is it iron? Is iron one? So it can be carbon dioxide, generally not iodine.
Sir, would it be C?
Could it be C? Hmm. Does
B. Oh boy.
the answer should be B? Because iodine is simple molecular, remember? Iodine is simple molecular. The iron would be a giant structure because of metallic structure, right? But simple molecular, iodine is simple molecular, so I need to make sure that we know that. The oxidation number of chromium in each of these cases, right? So if we're starting from here, the oxidation of state of chromium in the chromium trioxide would be what?
So C.
The answer is C. Okay.
Yeah,
What's actually the state of chromium in chromium
same.
trioxide though?
+3.
Right, therefore A is out since it's
Mm-hmm.
+3. What is the oxidation state in sodium chromate? That would be what's negative
Plus 6.
9, and then okay, so it's gonna be +6, so it has to be, well, it can't be B, right? And then the last one would be what, +6 again, right? So C is the answer, right? Elimination is
Mm-hmm.
relentless.
Yes, sir.
Lovely. So let's look at this now, the Born-Haber cycle, which is a repeat question. What type of heat change occurs with oxygen? Well, not oxygen. Oh my gosh, I see O and just say oxygen. With O here. What's heat change with O? So sodium and chlorine at gaseous stage and it becomes ions, right? What's happening here now? Will it be the first ionization energy of sodium? Because sodium becomes an ion, so it's the first ionization energy of sodium, yes?
Yes, sir.
Alright, so the first ionization energy of sodium. Alright, so hopefully everything makes sense so far. Right, so let's look at this now. When magnesium metal reacts with dilute nitric acid, right, that amount of moles of hydrogen gas is produced, the volume of gas occupying well, the gas would occupy at 298 Kelvin, right, 196 kilopascals would be that, right? So what would it be? Would be something here, or would it be, what's the response to the question? What do we do? Is it PV equal nRT?
Yes,
Yes,
sir.
sir.
Right, nRT get VV is equal to what? nRT over P, right? And we're just dropping all the answers, right? So what's the answer here? What's the answer? 0.512 times 2. Mm-mm.
B.
All right, B. Okay, right. What's happening here now? Which of the following phrases does not define? No, never mind. That's not the question. Which of the following diagrams best illustrates the line emission spectrum of hydrogen? This is the answer, right? A. As lambda increases, the energy levels become smaller, right? Or well, the as lambda will increase, right, and the energy levels will become successively closer to each other, right? Which of the following phrases does not define the rate of a chemical reaction?
C.
Rate of consumption of products, right? What's the overall order of this reaction? What's the order with respect to A?
first.
All right, and what's the order with respect to B?
Wait, is this the same question that we have been doing all along?
It's similar to it.
So the answer would be B.
So,
Okay, wait. Somebody say A, somebody say B. All right, hold on. What's the order reaction with respect to A though? Right, because we're seeing that when A is kept constant and B changes, the rate is kept constant. So what is that? Is that first, second, third? What is it?
First at 0.
Is it zero? What is zero order?
A is first order because 20 divided by 10, that's 2, and the 64 divided by 32, that's 2. As the rate, it's a 1-to-1 ratio, so it would have been first order for A.
So how do we determine the order for A though? We keep when A changes, right, and B remain constant, right? That's how we get the first order for A. And then for B now, is it first order, second order, zero
Yeah,
order? Or would be B? If B changes, the rate remain constant. What is that?
zero order,
Zero
Zero
order.
order.
The answer is B first.
zero order.
Alright. In the standard hydrogen half cell, a platinum electrode is used to B. Act as the inert metal connection between the hydrogen systems.
B.
Right? Lovely. The rate equation for the reaction present here, right, is given by that. So we see it's second order respect to hydrogen iodide, right, at 629 Kelvin at a concentration of 2 moles per dm cube. The rate of decomposition of it is given as this. That's the rate. What is the rate constant for the reaction? How do we find the rate constant K? K is equal to the rate divided by what? Concentration higher hydrogen, right? And the concentration of iodine. What's the answer to the question? What's the answer to the question? What would that be? The rate divided by those, or the answer?
A.
Alright. Give me a second. Alright, so let's move on to the next. Right, so what's happening here? The reaction, right, has a rate law given here. It if the half life is if 223 seconds, when the value of velocity constant, when the value of the velocity constant k at the room temperature of the reaction is, so what would be the velocity? If the half life is that, what is the velocity?
This was on 2015, I think.
Let's see.
The
All right, what is the working for it since we seem to be somewhat stuck?
the formula is T half is equal to ln2 divided by K.
Lovely. Right, and
Since
this
the
is.
half time is one, well, you can go ahead. No.
No, no, go ahead, go ahead. What's it? What was it you're saying? LN2 divided by
The
what again?
half life is 253, so you substitute by K, and I think ln2 is 693. I don't quite remember. Me did sort
It
that for
is.
paper too.
Is it
Uh,
zero? Is it 0.693?
yeah,
Okay. So I see your calculator give you some
yeah,
kind of
that.
a trick formula. All right. So I also did this when I was teaching rate of reactions,
Then you use the formula.
and the answer is what again? D. It has to be per second, right?
Dog.
It has to be per second.
Remember the rate per second, yeah.
Mm-hmm. So it has to be a small rate and it has to be per second. So you notice if it's not per second, those are out. And since this rate is huge, I would never have chosen that rate. Right? So that would be it there. Right? So the equilibrium now is established on the reaction of x plus y giving us z. Right? If the equilibrium concentrations of x is that, y is that, and z is that, which of the following is the value of the equilibrium constant Kc. Kc is products over reactants, right? What's the answer to the question?
For the reactants.
Repeat.
Dog. Let's say repeat
Sir,
too.
D.
To D.
D, sir.
All right, lovely. Moving on. So cytochrome oxidase is an enzyme needed in the living systems for the efficient metabolism of food in order to obtain energy. Traces of copper in the diet are needed in order to catalyze this reaction. Copper can catalyze this reaction due to its ability to. No, no, and no. See. Alright, so oxidation states lead to their oxidizing ability because it has more than one stable oxidation state, so it'll be free to catalyze the reaction. Right? So catalysis really deals with that. Or yeah. So the sample of freshly squeezed orange juice has a pH of 3.72. What is the hydrogen concentration for this? Hydrogen concentration is equal to what? 10 to the power of negative 3.7.
Until I
Lovely. What is the answer? So we're anti-log. What is the answer? Let me do the
B.
calculation. And the answer is, my calculator is telling me that B is the answer. Alright, lovely. Now who said chemistry was difficult? Come on now. In which of the following expressions express the solubility of this, right? So what would be solubility? KSP. For the products, right? If it's iron 3 hydroxide, therefore we know it's going to be iron 3 plus, right? How do we write it
there.
though? Do we use the stoichiometric coefficient? Go ahead. Is it A is the answer? You said A is the answer?
Yes, sir.
Alright. So we have that there. looking at the reaction of the rate of reaction here is, so with P is that, Q is that, Q squared is that, R is that. What is the order of reaction with respect to P? Is it first? So P is first, right? Q is going to be second. This is also the square law for this. So in order to get the graph, so it's going to be second generally as well, right? Because Q squared is going to be a straight line, and then this would
The
be zero.
screen is there. The screen.
The screen has not moved yet.
So
Professor
I'm not
Scott.
sure.
The screen stopped sharing.
No.
What happened? It went blank.
It just loaded, sir.
All right. Okay, we can't see it though. Zero. So that would be zero order. So what would be the answer
No,
then?
sir. Just pause for a second.
Okay. So the rate equation for this reaction would be, if R does not affect the rate, would R be in the equation?
Sir, hold on. Scroll up back to the question for a bit, please.
Okay, that is it. That's all the question is, no? That's it. What is the rate equation for this reaction? That is it. Can move on now?
Okay, sir. You can go back down to um the multiple choice.
Alright, so lovely. So since R doesn't affect it, we don't care about R at all. Alright, so I'll put it there. It's just second order with respect to Q. First order with respect to P. If R does not affect the rate, why would R be in the rate equation? It doesn't affect the rate. So why would it be a variable? Rate cannot be equal to something that has an R if R does not affect the rate. Lovely. Which of the following aqueous reagents can be used to distinguish between soluble carbonates and soluble sulfates? What's the answer here?
See.
Okay. Why? C. We tend to use barium chloride solution and hydrochloric acid, right? C. Right, so we're gonna get sulfates being produced, and then we can tell. Alright, you guys should be able to tell all these qualitative analysis things, right? So it should be fine. During the chemical reaction, disproportionation is said to occur. What is disproportionation? Right, so the substance will act as both an oxidizing and a reducing agent. We have oxidation and reduction happening at the same time simultaneously. Lovely. Barium chloride,
Dog.
lovely. Barium chloride is
Sir D.
yes. Barium chloride is more soluble in water than in aqueous sodium carbonate, and that is because LOL.
D.
Alright, the common eye effect. Okay. Are we sure? Because the common ion effect will push it out. Carbonate ions produce a precipitate. Marine animals such as oysters and other shellfish rely on slow precipitation of calcium carbonate to form their shells, which of the following properties helps this process. What's the answer here? The greater ionic product of calcium over carbonate, smaller solubility product or greater solubility product. It would be a smaller solubility product, right? So,
Yes, sir.
so what would be the answer, B or C?
So C.
Okay, so we're claiming that the greater ionic product of calcium over carbonate. Are we? Is that agreeable?
So yes, sir. So the way I'm thinking about it is, if we have more calcium and carbonate ions being added, then it would kind of shift equilibrium to produce more calcium carbonate.
Okay. Alright, so it would be something like that. Because gonna shift equilibrium to release more calcium carbonate ions. So if you have calcium carbonate and you have calcium ions and carbonate ions, if you increase the amount of calcium, we are gonna push the equilibrium to produce more calcium carbonate ions. Lovely. The standard electrode potential of tin, right, is presented here. In which of the following reactions is metal unable to reduce tin? What are we looking at? What are the values we're looking at? Unable to reduce tin. So are we looking for a higher value than 0.14 or are we looking for a lower value than 0.14? Negative 0.14. What are we looking for? A more negative or a more positive value? Which one? We're looking for
Sir, a smaller value.
a smaller value. Lovely, these the answer. Alright. Which of the following ions has the greatest polarizing power? Right? Which one has the greatest polarizing power?
Beryllium,
Why beryllium?
because polarity decreases in group 2, going down group 2, and beryllium is at the top of group 2.
Right? And we could also state
And
that the
it's
smaller.
smaller, so it has a better polarizing
Oh,
ability.
lovely. Smaller. Which of the following chlorides is of group 4 elements is the best electrical conductor?
A.
Somebody say A. You sure it's A? The answer would be germanium. Tetrachloride. So, silicon is a
It
good
would
thing.
have been lead because remember when you go down the group 4,
Oh, I'm so sorry.
um, the electrons start to
Sir, and
be
isn't
removed.
Isn't like germanium like what metal?
Yeah, I
Yeah.
just. Oh, my
They have
bad.
to be lead.
My bad. Right, because what I was thinking about, my brain went directly to electronics. Right, and the most suitable thing for electronics would have been silicon or germanium, but germanium is a better electrical conductor within electronics. So it's electronics I was thinking about. Lead is not suitable, but lead is the better conductor. Alright. So silicon carbide is a structure similar to that of diamond. What are the advantages derived from using silicon carbide ceramics when compared to steel? So I discussed this as well when I looked through group 4, when I was revising group 4. What's happening here now? It has a higher melting point and is more resistant to oxidation. Also, it's less likely to deform as well. So isn't it done so?
Pretty.
It won't deform, but it might shatter, but it won't deform. The use of the word is important. Hydrogen chloride, hydrogen bromide, hydrogen iodide are gases produced when solid samples of sodium chloride, sodium bromide, and sodium iodide respectively are treated with concentrated sulfuric acid, so which of the following gases will undergo oxidation? How does oxidizing power increase going down group 18, group 17 rather?
Reduces.
Reduces going down.
Mm-hmm.
Interesting. Therefore, what would be the highest one? What would be the ones with undergo oxidation then? With the bromide and the iodide, right?
Yeah.
You said no or yes?
I say yeah, yeah, yeah.
Alright.
Because I think it's in the Susan Maraj book that they say when you want to prepare those, you have to use sulfuric acid instead.
I can't believe you know Mirage. That book is lovely, you know. The book is lovely. It's
That
like
book saved me, oh.
it's a storybook. You know, I recommend it to 4 year olds. I read it to your children every night when they go to bed. It's a lovely book, right?
Limited. Yeah, exceed your limited now. Because why would
I
you want to traumatize a 4-year-old with chemistry? Be for real.
I was the only person who was really interested in chemistry in primary education when I went to preparatory school. All right, so 35. Which of the following oxides of elements of period 3 are correctly matched with their acid-base character? This is a point of contention. Is it all of them? Is it all?
Which group is phosphorus in?
But not answer that question though. Me, shame. Shame will kill me. Uh, me not answer that question. Me not answer it. Which group is
From
it?
me then the paper too, me don't know me put the
Sir,
group. Yeah.
Go ahead. Go ahead.
sir, is the answer C?
Alright, interesting.
Sir, isn't aluminum oxide
Yes,
Yeah,
thermically?
amphoteric. But the
yeah.
thing, a lot of persons, okay, so when we were doing this, right, we went to different Cape teachers, are saying that, okay, yes, amphoteric oxide, but that still means it has acidic and basic character. Isn't that the definition of amphoteric? So some persons are
Yes.
saying that D will still be the answer. And some people are saying that no, because it's acidic as well, C will be the answer. So it depends on your interpretation of the question. If you get what
I'm
I'm
gonna feel
saying.
like overdo it in the aspect of if it's amphoteric, they should put amphoteric there. Because why would they put base and leave off the acidic part?
Mm-hmm.
So just
Nice.
work with the thing here.
Oh, we work with C. Going with amphoteric, but some people are saying that that does still mean it's basic in character. But it depends. It depends. It depends. When you look at university chemistry, first year university chemistry, when talk about solvent systems, acid and bases, because you have like five definitions of acids and bases, right? Not just the ones that we look at this level, right? So that will now determine, depending on the solvent, it would be basic or acidic. But gonna look at something else, right? 36, which of the following pairs of properties increases on descending group 2? So what happens when we descend the group? What increases when we descend the group?
B.
Lovely.
B.
Right. None of the chaos of Mr. Chemistry are easier than there's a science them, It's very easy. Look at this now. We're supposed to know name, right? Well, each oxide may be used once, twice, or not at all. Lovely. So, which of the following oxides is an oxide of silicon? Come on, guys. We need to finish this. What is the oxide of silicon? Hello? Is anyone there?
B.
B as in boy, lovely. Right? Which of the oxides will be oxide of sulfur?
D.
You sure?
Mm-hmm.
How much you have
Sulfur
it?
dioxide is a gas. One thinking one.
You
And I
sure?
tell that already?
You sure?
Sure, sure, sure.
Alright, lovely. The ionic equation for the formation of chromium hydroxide from chromium 3 sulfate and dilute ammonia is? How would that be now? So we have the chromium. Um, hmm. What an interesting equation. Oh, the sulfate are spectators. Alright, lovely. Sulfate and ammonia is spectators. So what's the answer here? What would be the formula for chromium hydroxide?
Cr2, um, OH3.
Wouldn't be Cr2. It would just be CrOH3. Therefore, this is wrong and that is most definitely wrong. So it's either these two. And I've never seen
Dog.
liquid hydroxide before in my entire life. So it must be aqueous. Look at the things. This is a solid ion? No, no, no. What rubbish. Right? So we can look at that there. Which of the following properties does not describe transition elements? They do form complex ions. They do share and will show variable oxidation states. Often referred to as non-magnetic. Who tell you that?
C.
Them have paramagnetism and
Sorry,
diamagnetism and
C.
ferromagnetism. Lovely, C is the answer. Alright. Moving on, the sharp increase from copper to zinc is caused by filled what? S and D orbitals, right? Because from copper we go to zinc. Zinc is filled, right? Is C the answer? Is it caused by the d orbitals only? I mean, in copper and zinc, the s orbitals are already filled. So I think it would be the d orbitals only, right? Yes, no, maybe so. Probably.
Sir D.
Wait, D as in dog or B as in boy?
B.
As in?
Boy.
Okay, lovely. Because I'm not hearing it properly. The insolubilities of group 2 sulfates make them very useful for diagnostic medicine because they appear opaque in X-rays. Which of the following sulfates is most commonly used for X-rays? Barium sulfates.
A.
Yes, A. If you use magnesium sulfate for X-rays, I think you should be fired from the medical profession. I think your license should be revoked. Um, 43. Elements can be classified by the response to externally applied magnetic fields and as diamagnetic, paramagnetic, and non-magnetic. Which of the following elements is considered at the highest degree of paramagnetism? I went through this as well. Highest degree of paramagnetism.
B.
B as in boy.
Mm-hmm.
All right.
Sorry, I can't explain why 41 is boy.
Okay. Okay.
Because
What do
like
you
I've
think?
been going through videos too, and at one point it was A.
All right. So look at copper and zinc for me, please.
Yeah.
You can see well the electron configurations.
Copper would have been the 3D10.
Isn't copper the one with the unfilled s orbital?
Yup.
What in the Lord's? Okay, hold on. That was a slip right there. Yeah. Hold on. So if copper is it is A is the answer, right? My bad there. Is the s orbital. Because the only difference between copper and zinc is the s orbital. My bad. I'm so sorry. I must have caused some heart attacks. I apologize. Right? So the only difference between copper and zinc would have been the unfilled s orbital in copper. Which of the following compounds would produce the lowest pH when 0.5 moles of it is bubbled in 1 liter of water? Or will be the lowest pH?
Um, A.
Why A?
Because it would create an acidic solution
Well, to B will give create a acidic solution. So explain why A.
that will create sulfuric acid, I think.
Mm-hmm.
I don't remember.
It will create sulfuric acid, right?
Yeah, it
Mm.
will create sulfuric acid.
Alright, it has a very high affinity for water as an oxo acid, which you'll learn um, at higher levels of chemistry. And know what deduction can be made from the following reactions of iodine and chlorine with sodium thiosulfate. Chlorine is a stronger oxidizing agent, yes? Is that what it's saying?
In theory, it is.
No, you sound like a chemist.
Them
In
said to
theory.
deduce. They said to deduce it. They make it sound like said it deviates from what is already in the theory. Yes, that's the answer.
Yeah, it has to be that. Alright, so that is the end of. This is what, 2020? Well, 2017, yeah? 2017.